factoring time into costing. So up until this point, you should have covered capital improvement planning. You should have read chapter 7 and also gone through my slides as a supplement to the readings for this lesson. So now what we're going to do is we're going to talk about uh, factoring in time when we're trying to make decisions regarding costs. Because as you all know, that over time, the value of money changes. So as administrators are making investments in major capital improvement projects and they're making investments over time, they have to factor in the value of their money in today's dollars as opposed to tomorrow's dollars or vice versa, right? So you have to make sure that you're factoring in time when you're making large monetary decisions. So one way to do this, and Mike Zell talks about this in chapter 7, is through compounding, okay? And basically compounding is simply applying value increases over time to a present dollar amount. So here I have some variables on the screen where FV equals the future value, PV equals the present value, R equals the rate, and N equals a number of years of time, a number of units of time, if you will. So in most instances, it's years, okay? So what we're going to do here is we're going to basically just look at the formula, and then I'm going to show you a little later on how to actually do this in Excel, okay? Or at least show you an example in Excel. So looking at our formula here, and given our variables, we have the future value sub n equals the present value plus the present value times r, or the present value times 1 plus r, which is the rate, your rate of interest, okay? And so when you do this, that will allow you to compound to see how your money will be affected in future years. Now, the opposite of this is called discounting. And discounting basically is converting estimated future values to the present value, or taking a value from the future and bringing it back into today's dollars. Okay, and so a popular way to do this is using an annuity formula. Okay, on page 318 in edition 9 of the Mike Zell text, he gives some examples of discounting where he has some projects here, and he shows what that project will be worth in today's dollars, given the future. So the issue here basically is saying that, you know, you're promising some administrators that the project is going to realize some sort of benefit. However, you go and look at the numbers to see, okay, what's the real benefit in today's dollars? You're telling me that in 5 years this project will be worth, you know, $2,100, but what is that worth in today's dollars? So basically, he gives an example using that. Now, the annuity formula does the same thing that the projects that he outlines on page 318 does, but the only difference is that the annuity formula assumes the return on the project to be constant. And so when you have a constant value for your return on your investment, then you can just basically plug all your values into this formula instead of doing the calculation several times, given how many years you have, right? So if you have 5 years, then you have to do the calculation 5 times. If you have 10 years, you would have to do the calculation 10 times. So instead of having to do the formula, the calculation multiple times, the annuity formula basically will allow you to just do it one time, plug in your variables, and you should get the same answer. And if you like, go ahead and try that. So what you can do is you can look at one of the projects on page 318, do it manually, and then, as a matter of fact, take the one that has a constant return dollar amount. I think both of them do. Do it manually, the long way, and then turn around and use the annuity formula, and you'll notice that you get the exact same answer. Okay, so and also too, when you think about annuity formulas, right? Think about loans, okay, or think about benefits or something that you investments over time. Okay, when you get a loan, they're basically using an annuity formula to basically tell you what you will be paying in today's dollars. Okay. Another way to look at that would be if you won the lottery. Nevada doesn't have a state lottery, but if you were in a state that had a state lottery, right? The jackpot might be $50 million, but then they'll tell you after taxes and other deduction that you might bring home about 28. Okay, well, while some of that goes to taxes, a lot of that is being reduced because they're making the assumption that you're going to have a 30-year payout, right? But if you get a lump sum, then what they'll do is they'll take that amount that you would have received in 30 years, and then they just take that amount and reduce that amount to today's dollars. So, in other words, $50 million 30 years from now might be only worth 30 today. Okay, because again, the value of money changes. So, the next formula that we're going to look at here is the net present value. And the net present value is a simple cost benefit analysis calculation. And here you can see our variables we have. We have the benefits, the cost, the discount rate, the time period, and the number of time periods. So when you look at the formula here, right, we have the NPV, the net present value, equals the sum of the benefits for a given time minus cost for a given time divided by divided by 1 plus the rate to a given taken to the power of a given time. Now, for those of you all who know statistics and who know math, anytime you see the sigma symbol, that basically tells you that you need to add a bunch of things together, all right? And you need to do a formula multiple times and basically take the total of your product of those formulas and just add them together. So a lot of times people tend to see the sigma statistics symbol or the Six Sigma Greek symbol in statistics and become intimidated, thinking that this is a wacky, complex formula. But all it's telling you is to do this formula multiple times by however many times n is and just add it together.